If you've ever wanted complete control over your creative workflow, this tool might just be what you are looking for. Meet ComfyUI, a powerful node-based interface that lets you design your own generative AI pipelines from the ground up. It's open source, free to use, and runs locally on your computer, giving you total control over performance, privacy, and creativity. But let's be honest, ComfyUI can be overwhelming at first. The endless nodes, workflows, and settings can feel like learning to fly a spaceship. Even after using ComfyUI for a while, I still learn something new every single day. Let's explore and learn together. We'll turn complex ideas into simple steps, experiment with new workflows, and push the limits of what's possible with this incredible creative tool. So, what exactly is ComfyUI? In simple terms, ComfyUI is a node-based workflow system for generative AI, mostly used for text-to-image models like Stable Diffusion or video models like One. Each node in ComfyUI represents a building block. It could load a model, process an image, apply a filter, or handle prompts. You connect these nodes together like pieces of a puzzle, defining exactly how your generation pipeline works from start to finish. This visual, modular approach makes ComfyUI incredibly flexible and transparent. You can see every step of your generation process and tweak it in real time. One of the biggest strengths of ComfyUI is its community. Thousands of developers and artists are constantly building new custom nodes, extensions, and workflows. This means you're not just using a tool, you're joining a living, evolving ecosystem that's shaping the next generation of AI creativity. From photorealistic portraits to anime art, from advanced control workflows to video generation. If you can imagine it, chances are someone's already experimenting with it in ComfyUI. Alright, let's talk about how to actually get it running. The great thing about ComfyUI is that you can run it entirely on your own computer. No internet connection or cloud service required. However, to get the best performance, it's highly recommended to have an NVIDIA GPU with at least 8 GB of VRAM. That's usually the minimum you'll need to generate images smoothly, without running into memory issues or slow processing times. But if your setup doesn't quite meet those specs, don't worry, there are cloud options too, including the official Comfy Cloud and third-party GPU providers like Runpod. A full video on how to set up ComfyUI on Runpod will be coming soon, so stay tuned for that. Let's start with running it locally. There are a few different ways to install ComfyUI, depending on your experience level and how much flexibility you want. The simplest way is to download the desktop version of ComfyUI for Windows. It's basically a one-click solution. You just install it, open it, and you're ready to go. This is great for beginners, but it's a little less flexible if you want to customize or update it frequently. The next option is the portable version from ComfyUI's official GitHub page. This version runs directly from the source files and gives you full control. It installs a portable Python environment that is only used for your current Comfy package and doesn't interfere with your system environment. It takes a bit more setup, but it's perfect if you like tinkering or use an AMD GPU. This version also runs on Apple and Linux systems. And finally, the method I personally recommend, using Stability Matrix. Stability Matrix is a launcher and manager built specifically for AI tools like ComfyUI and Stable Diffusion. It makes installing, updating, and managing your environments incredibly easy, since it is installing the portable version and using a graphical user interface to launch Comfy. You can install multiple different ComfyUI versions to test new updates before committing to them and have a shared folder structure for models and outputs. In this case, we'll be using Stability Matrix as our main setup, since it gives you the best management and ease of use for creators who want a smooth experience. But if you prefer a different option, I will leave links to the official installation guides in the description. Now, head over to the Stability Matrix website, click Download, and choose the stable version. Once it's downloaded, unzip the folder and run the .exe file to start the installation. When prompted, make sure to select Portable Mode. That way, you can easily move your installation to another drive later if you run out of disk space. Next, in the Packages menu, select ComfyUI and choose a diffusion model to get started with. Don't worry about choosing the wrong one, we will get deeper into models later on. Let the installer do its thing. Once it's done, you'll be ready to launch ComfyUI for the first time. But before you hit launch, there's one essential extension we need to add, something that isn't included by default, the ComfyUI Manager. This plugin adds a built-in interface for browsing and installing custom nodes and models. so you don't have to mess with command line tools. To install it, select your ComfyUI package and click the puzzle piece icon. Search for Manager, find ComfyUI Manager, check the box next to it and click Install. With this setup, you're ready for your first launch. When you hit launch, you'll see the window switch to a command line interface. This is your terminal, and it shows what's happening behind the scenes. Things like the current status, the progress of running jobs, and any errors that might occur during the process. In the top left corner, you'll also find a button that lets you stop or restart your running ComfyUI instance whenever you need to. You might notice that it takes a little while for ComfyUI to start up. That's completely normal. During this time, it's scanning all your installed nodes and configuration settings before loading the interface. Just keep in mind, the more custom nodes you install later on, the longer your startup time will be, so it's a good idea to only keep the ones you actually use. As soon as you see the line with an IP address, you can click the link or the Open Web UI button on top to launch the Comfy interface. A new browser window should open and you will see the interface presenting you a variety of thumbnails. This is the templates library of official pre-made workflows designed for different models, use cases, and providers. It's a great place to explore what ComfyUI is capable of when it comes to creative AI. Feel free to open a few templates and study how the nodes are connected. It's the perfect way to start understanding how the node-based workflow actually works. Now, at first glance, these templates might look a bit intimidating or confusing, and that's completely normal. But most of them are built from simple, logical steps, and they'll start making perfect sense once you learn the basic principles behind them. Let's take a quick look at the ComfyUI interface and get familiar with its layout and options. Starting in the top left corner, click on the ComfyUI logo to open the main menu. From here, you can create, open, export, or save your workflows. Pretty much everything you need to manage your projects. Just below that, you'll find the settings menu, which you can leave as is for now. The Browse Templates button opens up the template library you just saw when opening Comfy for the first time. Let's move on to the sidebar, where you'll find a few important sections. First up is the Queue panel. This is where you can track all your generations for the current session. It shows you what's currently running, what's waiting in line, and what's already finished. If you start more than one job at a time, they'll appear here in the queue and update automatically as each one completes, or if an error occurs during generation. Keep in mind, this list resets every time you restart ComfyUI, so you won't see previous sessions here. But don't worry, your generated images are still safely saved in your output folder. Just below the queue panel, you'll find the nodes library, a complete list of all the nodes currently installed in your setup. It's a quick and convenient way to search for specific nodes and see a small preview of what each one does. You can also add nodes to your favorites, so they're always just one click away when building new workflows. Next, there's the model library, which gives you a clear overview of all the models stored in your models folder. Each model is neatly organized, and you can load it instantly with the appropriate default node simply by clicking on its name. And finally, we have the Workflows panel, where all your saved workflows are listed. You can organize them, load them quickly, or mark your favorites for even faster access later. The final button opens the same template library we were looking at before. A bit further down, in the bottom left corner, you'll find a few more useful sections. First, there's the Help Center, which includes handy links and information, a great place to visit if you ever need to check the last updates or take a look at the official docs. Below that, you'll see the Keyboard Shortcuts panel, listing all the key combinations that can speed up your workflow once you get comfortable with the interface. And finally, the Logs panel. This shows the same real-time information you'd normally see in the Stability Matrix console. It's really convenient to keep this open, so you can monitor everything happening inside ComfyUI directly in one window. Down in the bottom right corner, you'll find the Canvas bar, your main set of tools for navigating the workspace. Here, you'll see the Hand and Select tools, which let you move around and select nodes on the canvas. You'll also find zoom controls, a Fit to View option, and a toggle to hide or show node links for a cleaner view. You can also show or hide the minimap either by pressing Alt-M or by selecting it from the Zoom drop-down menu. It's a handy way to keep track of your workflow layout, especially when you're working on larger, more complex node graphs. And finally, at the top of the interface, we have the menu bar. On the right side, you'll see the Run, Cancel Current Task, and Clear Queue buttons. These control how your workflow is processed. The Run button starts processing your workflow using the current node settings. It also offers a few different modes depending on how you want to work. Next to the Run button, you'll see two smaller buttons that let you clear your cache and unload the current model from your GPU's VRAM. These are useful if you're switching between models or just want to free up memory without restarting ComfyUI. Right beside those, you'll find the ComfyUI Manager button. This opens a window where you can browse, manage, and install custom nodes directly inside the interface. No need to touch the command line. We'll take a closer look at how to use it in the next video. Finally, in the top left corner, you'll notice your workflow tabs. These let you switch between multiple open workflows, just like browser tabs, which makes it super easy to multitask or compare different setups. And that covers the current layout of the ComfyUI frontend, based on version 0.367. Since this project is constantly in development, the interface might look slightly different depending on when you're watching this video. The core functionality should remain the same. And if there are any major updates, I'll post a new video and link it right here in the description. Alright, now let's get practical and build our very first workflow. You could just load a basic setup from the template library, and that's a great way to explore. But in my opinion, the best way to really understand how ComfyUI works is to build one from scratch. By doing it yourself, you'll see exactly how each part connects and what role it plays in the image generation process. Once you get that foundation down, everything else, even the more advanced workflows, will start to make more sense. We're going to start by creating a simple text-to-image workflow using Stable Diffusion. It's the perfect beginner-friendly example to help you understand how everything in ComfyUI fits together. To begin, create a blank workflow by clicking the plus icon in the main menu. Once you're on the empty canvas, double-click anywhere. This opens the quick search bar where you can look up and add any of the nodes you currently have installed. From here, we'll start adding the core components that make up a basic Stable Diffusion pipeline. In the search bar, type KSampler and select it from the drop-down list. The KSampler is basically the heart of your workflow. It's the node that brings all the other components together. It handles the actual image generation process, taking your inputs, running them through the model, and finally outputting the finished image. In general, every workflow in ComfyUI flows from left to right. You'll find the input connection points on the left side of each node and the output connection points on the right. If you look at the KSampler node, you'll see it has multiple inputs and outputs along with several parameter settings. These parameters control how the node operates and define the logic of the generation process. Under the hood, every node is driven by custom Python logic that defines how it behaves. That means you can access advanced functionality and automation, all without writing code manually. Each node takes in some kind of input, does a bit of work or processing, and then sends the result out as an output. You can think of them like functions in programming. Each one has a specific job, and when you connect them in the right order, they work together to complete a bigger task, like generating an image or video. To connect a node, simply click and drag from one of the connection points out into the empty space, then release your mouse button. A small menu will pop up. It'll show a filtered drop-down list of all compatible nodes. In this case, we want to load a model checkpoint, so choose the Load Checkpoint node from the list. You'll see a new node appear, automatically connected to our KSampler. You might also notice that each connection point has its own color code. That's because different types of data use different colors, making it simple to spot which nodes can connect. For example, model connections are always shown in lavender. If you try to connect a yellow clip output with an orange positive or negative input, you will see that they can't be connected. To load a model into the Load Checkpoint node, just click on the drop-down menu and select the model you downloaded earlier during the installation. If you don't have any models yet, no problem. Let's quickly grab one. Open up Stability Matrix and click on Model Browser in the sidebar. This opens the built-in Civit AI integration, which makes finding and downloading models incredibly fast and easy. In the drop-down for model type, choose Checkpoint, and under Base Model, select SDXL 1.0. From here, you can browse through a huge collection of models, each with different styles, strengths, and looks. Take your time, explore the previews, and when you find one you like, just click the Download button on the right. You'll see a download pop-up appear in the bottom left corner, showing the progress. Once it's finished, the model will be automatically saved inside the Stability Matrix Models folder. And the best part is that this folder is shared across all your installed packages. That means you only need to download each model once, no matter how many versions or setups you experiment with. It keeps everything tidy and saves you from having to deal with multiple downloads or custom folder links. But what exactly is a model anyway? In simple terms, a generative AI model is a trained file built from huge amounts of data. In this case, millions of images paired with text descriptions. During training, the model learns how words connect to visuals. For example, what a cat sitting on a windowsill should actually look like. But here's the interesting part. The model doesn't just memorize images. Instead, it learns by adding random noise to them, and then training itself to remove that noise step by step until the original image reappears. Over time, it becomes incredibly good at reversing that process, turning noise back into meaningful, detailed images. Once it's trained, you can give it a text prompt, and it uses everything it has learned to generate a brand new image that matches your description. Inside the model, the component that does this work is called the U-Net. The U-Net is the part that actually performs this denoising process, starting from pure noise and gradually refining it into a clear image that matches your text prompt. So when we load a model in ComfyUI, we're really loading the brain that learned how to turn noise into art, the system that understands your words and brings them to life, one pixel at a time. Once you've selected your model in the checkpoint dropdown, we can move on to connecting the next parts of our workflow to the KSampler node. Start by dragging a connection link from the positive input. This is where we'll connect the clip text encode node. This node is where you'll write your prompt, describing everything you want to see in the final image. Now, the negative input works the same way. It tells the model what you don't want in your image. Since it uses the same type of data, we can simply copy and paste our positive prompt node and then connect that duplicate to the negative input. This gives us two separate prompt inputs, one for the positive prompt and one for the negative prompt, which together help guide the model more precisely toward the result we want. If you paid attention to the clip node's input points, you might have noticed that they match the output points in our load checkpoint node. That's because our model has a text encoder baked into the model. And what exactly is a text encoder? In essence, it's the part of the model that translates your written prompt into numbers, or more precisely, into a form of data the AI can understand. It takes your words, breaks them down into meanings and relationships, and passes that information to the image generator. Think of it like a translator between your text and the AI's visual imagination, helping the model understand what you want to see before it starts painting the picture. Let's quickly connect the nodes and move on to the last input of our KSampler. Drag out the latent image input and pick the empty latent image node from the menu. This node defines the settings for our image size. Basically, it creates an empty canvas for the model to work on. Back in the early days of Stable Diffusion, most models were trained on 512 by 512 pixel images. If you try to generate larger images, you'd often see weird artifacts or blurry details because the model simply wasn't trained to handle higher resolutions. But with Stable Diffusion XL and newer models, that's changed. These models have been trained on much higher resolution data, so 1024 by 1024 has become the new standard size for clean, detailed generations. Of course, you can still experiment with other sizes. Just keep in mind that images much larger than 1 megapixel will start to produce artifacts at some point. As you might have noticed, we still have two outputs left to connect: the VAE output from the load checkpoint node and the latent output from the KSampler. Let's start with the VAE. Drag a connection from the VAE point and open the search menu. Then select VAE Decode and you'll see a new node appear on the canvas. VAE stands for Variational Autoencoder. It's basically the part of the model that knows how to compress image information and then reconstruct it into full detail. The VAE Decode node is what takes the latent image data coming from the KSampler and converts it into a visible image you can actually see. Think of it like developing a digital photo. The KSampler generates the hidden, encoded version of the image, and the VAE Decode node develops that into a clear, full-color result. The good news is that, in SDXL, the VAE is already baked right into the model checkpoint, so you don't have to load it separately. It's ready to go right away. Now we just need to connect the VAE Decode node to the KSampler. You'll notice the connection points share the same color, which makes it easy to spot where they belong. Even though the outputs have different names, they're passing along the same type of data, so you can safely connect them. With that done, there's only one thing left: outputting the final image. To do that, drag out a link from the image connection point on the VAE Decode node, and from the menu, select Save Image. This node will display the finished image from your workflow and save it right into your output folder. Here you can also set a custom file name and choose a subfolder for your output location. That way, you can keep your generations organized, especially once you start creating multiple workflows or working on different projects. You can find your generations inside the images folder located in the Stability Matrix directory on your hard drive. Just like with the models, this folder is shared across all your installed packages, so your output files are always stored in one convenient place. Congratulations! You've just built your first workflow from scratch in ComfyUI. That's a big milestone. You've connected all the core parts, learned what each one does, and now you're ready to run your first generation and see your AI creation come to life. Write something into the positive prompt node and click the Run button. Make sure you have the logs panel open so you can watch what's happening in the background. As the workflow runs, you'll notice one node gets a green border that shows which node is actively doing the work right now. When that node finishes its job, the green border moves to the next node, and then the next, step by step, until the whole process completes. If something goes wrong, you'll usually see an error message in the logs, and the highlighted node will stop and the green border will turn red. That's your sign to start troubleshooting. Otherwise, sit tight for a few moments and you'll see your image appear in the Queue panel or Save Image node. To wrap up this video, let's take a closer look at the KSampler settings. These are the controls that define how your image is generated, and adjusting them can completely change your results. Starting at the top, we have the seed value. The seed is basically the starting point for the random noise that kicks off the generation process. Think of it like rolling a die. Every number gives you a different initial pattern of noise, which leads to a slightly different image. If you keep the same seed and settings, you'll get the same result again. This is really helpful when you want to reproduce or tweak an image later. If you want something completely new each time, you can either change the seed manually or set Control After Generate to anything else than fixed, which automatically picks a new seed every time you run the workflow. Next up is steps. This controls how many denoising steps the model takes to turn random noise into a finished image. You can think of each step as a single brushstroke in the image's evolution. More steps mean finer details and smoother transitions, but also longer processing times. For SDXL, something around 20 to 30 steps is usually a sweet spot. Then there's CFG, which stands for Classifier-Free Guidance. This setting controls how strongly the model listens to your prompt versus how much freedom it has to improvise. A lower CFG value, like 4 to 6, gives the AI more creative freedom, sometimes resulting in softer or more abstract images. But if you go too low, the image can start to look a bit flat or bland, since the model isn't being pushed hard enough to emphasize contrast and detail. On the other hand, a higher CFG, around 7 to 10, makes the model follow your prompt more strictly and adds more contrast and definition, giving the image a stronger, more focused look. If you push too high though, things can start to look over-sharpened or unnatural. So it's really about finding that sweet spot where your image feels both vivid and believable. Next, we have the sampler name. This determines which algorithm the model uses to perform the denoising process. You'll see names like Euler, DPM++, DDIM, or Hoyne. They all follow the same diffusion logic, but handle the noise removal slightly differently. Some produce sharper details, others smoother or softer lighting. There's no best sampler. It's worth experimenting to see which ones give you the results you like most. Under that, you'll find the scheduler, which controls how those steps are distributed over time. The simple scheduler spreads them evenly, which works well for most cases. Other options like Keras or exponential adjust how quickly or gradually the noise is reduced, which can slightly affect things like contrast, sharpness, or overall image consistency. There are some sampler scheduler pairs that people recommend because they tend to work well together. But honestly, it's worth trying different pairs yourself. you'll start to notice which ones give you the look you like. And finally, we have the denoise value. This tells the KSampler how strongly to apply the diffusion process. A setting of 1.0 means full denoising. The model starts from pure noise and generates an entirely new image. Lower values are especially useful for image-to-image or in-painting workflows, where you want to modify or improve an existing picture without completely changing it. Together, these settings give you precise control over how your images are created. Once you start experimenting with different combinations of seeds, steps, samplers, and CFG, you'll quickly discover just how much control ComfyUI gives you over the final output. Don't be afraid to play around. Change one setting at a time, compare results, and see how each adjustment affects your image. The beauty of ComfyUI is that it's a sandbox. Everything is visual, flexible, and built for creative exploration. So open it up, start connecting nodes, hit run, and have fun seeing what kind of art you can bring to life. In the next video, we'll take things a step further and explore custom nodes and more workflows. Thanks for watching, and if you found this helpful, make sure to like, subscribe, and hit the bell so you don't miss the next part of the series. Leave a comment with feedback or any issues you encountered. Now go experiment, and I'll see you in the next one. Cheers.